Hello everyone, I'm Frank and welcome to Frank Puzzles. In the month of October, I'm uploading two videos every day. One that's going to be a very easy or easy level difficulty level puzzle, and one that's going to be average, hard, or very hard difficulty level puzzle. And this is today's hard level difficulty puzzle, and it's called Compression by Jade Dyer. And I'm not looking forward to this because Uh, it's a hard one, and it's a region sum line one, and I'm not that great with region sum lines. Anyways, here are the rules. Normal Sudoku rules apply. That means place the digits 1 through 9 in every row, every column, and every box. This one. Along a line, the sum of digits on the line is the sum of the digits on the line is the same in each region the line passes through. Different lines may have different sums. So this is a region sum line. One way we also describe it is the box borders of the 3x3 boxes separates a region sum line into regions that sum to the same number. So for example, these three digits must add up to what this digit adds up to. If you have these four digits must add up to what these three digits add up to. These three digits must add up to what these two digits add up to, which must add up to what these two digits must add up to, etc., etc. And those are all the rules. Okay. Region sum lines can be very hairy and it can be very difficult. So I don't know how long this is gonna take. But if you want to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay. Oh boy. This is going to be tough. I can just feel it already. Okay. So this has to be 6, 7, 8, 9. And this is 1 through 6. These 4 add up to these 2. These 2 add up to these 2. These 2 add up to these 3, which add up to these 2. These 4 add up to these 2. Oh, that's interesting. So one thing about, region sum lines that make things interesting is that you start getting some sums which are very unique. So we know specifically these 3 have to add up to the same as these 5. Because we know that this set equals this set, and this set equals this set. So since these are the same, these 5 has to be the same as these 3. Oh boy. Okay, I don't know what that really tells us, unfortunately. Okay, so what else do we have? These 2 add up to these 2, which add up to these 3. That's interesting. These 2 add up to these 3, which add up to these 2. Huh. Okay. Hmm. Really, you're looking for things that complete like boxes or complete sets, rows or columns, essentially. Um, Interesting. Okay. We know these 3 have to add up to these 5. Because these 4 add up to these 2. These 2 add up to these 2. So this one is the same as these 2. So let's remove the blue because it's hard to see. Hmm. Okay. So this is at least 15. I don't know what that really tells us. these 3 add up to the same as that. This 1 adds up to the same as these 2. So this big thing is the same as this set of 5. These 2 is the same as those 3. Which is the same as those 2. Okay, maybe we have... these 2 add up to these 2, which add up to these 3. These 4 add up to these 3. I don't do well in these. Anyways, okay, let's just try to color things so that they're equal. They match each other. Where did I do that? Anyways. This is yellow, which would equal this yellow, which equals this yellow. This will be blue with those blue. This is orange, and orange is going to be dark, dark, dark. I'm going to make this light and this light. All right, I guess that's medium. And this is light with that one. So we know these 5 add up to these 3. Not sure what that tells us. Oh, wait. That's interesting. These, yeah, so these 4 add up to these 6. Therefore, these 5 add up to these 3, which includes this set of 5, which must equal these 3. Right? So this is at least 15, because it's 1, 2, 3, 4, 5. These 3 equal these 5. I don't know if that tells us very much, though. Oh. Yeah, that tells us something, too. Okay, so these 3 equals these 5. Okay, so actually, let's clear all these. The most important thing is, so yeah, these 3 equals these 5. So the blue and the orange are the same, because this set equals this. That blue set is also contained in some yellow set, which must equal this pink set. This pink set is also included in this red set, or I guess let's make it green, I guess. This green set, which matches, which is the same as this red set. So we know this is at minimum 15. So the blue has to be 15. So 15 plus 1 and 2 would be 18. And that that sums to the same as what purple is. So this is 18. This is at most 1 and 2, and this adds up to 21. So this has to be at least 21. I don't know if this gives us anything else. So, like, can this 5 set be contained with a 3 set of something, right? So the thing is, what we know is that this has to be at least 21. I don't know what that tells us, though, right? So there are 3 degrees of freedom right now that we have, and the thing is, if I look for another set of 5 that has to equal a set of 3, then we're guaranteed another set, right? So then that if say this set of 5 equaled, out of this set of 5 there was a set of 3 in there that equaled another set of 5, then that would be 15 plus at minimum 3, so that would be 18, which would make this with 18, which makes this set 1 plus 2, which means that has to be is equal to this set, which would be 21, and then this set plus 1 and 2 would be 24, and therefore this would have to be 7, 8, and 9. And then this would have to be 6, which would mean that's 1, 2, or 3. But the problem is I don't know if we have that thing here, right? I just saw this in essentially where a set of 5 has to equal a set of 3, and that limits things, right? So we have 3 sets of those, and we're looking for a 4th one, right? So this is a set of 5. A set of 3 would be 1, 2, 3. So 1, 2, and 3. So this 2 equals this set. These 3 equal this 4. This set, so these are equal. We don't know anything about this, right? This value doesn't translate into this box anywhere. So this is 29, right? If this is 29, sorry, this is 21. So that could be 4, 8, and 9. So it's 4, 5, 6, 7, 8, 9. So far, nothing. Oh, one interesting thing. This cannot be 1, 2, and 3 then, right? Since this is at minimum 4, 8, and 9, this has to be 1, 2, and 3. I'm sorry. If this is 1, 2, or 3, where is a 1, 2, 3 in column 1? You can't find it because there's only 2 spaces now left. So we know this cannot be 6. If this is 6, this would have to be 1, 2, or 3. So we can't find a 7, 8, or 9 here. So this cannot add up to something. This cannot add up to another set of 3. So we can throw that away. So this has to be 7, 8, and 8 or 9. So it cannot be 1, 2, or 3 here. I think since it's 21, there has to be 2 out of 7, 8, or 9 here. So this is 7, 8, or 9. This has to have 2 out of 7, 8, or 9. So you cannot have any 7, 8, or 9s in this column anymore. Oh, that's interesting, which forces that to be 7, 8, 9. That's 7, 8, 9. Interesting. I like that. That was clever. So we know that this is the end, at least for now, right? because you cannot have 7, 8, 9 here. So this means you could only have 23 at most. So this is at most 23, which means this one's at most 20, which means this is at most 17. So this has to add up to at most 17. So this is at least 3, obviously. This is at most 17. So that would be 1, 2, 3, 4, 7. Possibly. So 1, 2, and 3 are taken into account. So this cannot be 1, 2, or 3. So this is 4, 5, 6, 7, 8, 9. And this can only be up to, so 1 and 2 can be here. And then 3 can be any of these. 4, 5, 6, 7. So this is 7 at most, right? So this is 7 at most. So this is 1 through 6. This is 23 at most. This is 20 at most, but it could be down to 18. So 1 could actually be there too. So this is 1, 2, 3, 4, 5, 6. This is only 1 of 4, 5, and 6. This has to have, so if you, for a 7, and 8, and 9 that add up to, if you have 3 digits that add up to a 7, an 8, or a 9, you're guaranteed to have 2 out of 1, 2, 3 be represented. So therefore, there's 2 from 1, 2, or 3 here. Where are they going to be in column 1? They have to be in these specific 2 spots. So this cannot be 4, 5, or 6. These have to be the 2 out of 3 from 1, 2, or 3 that are here. There's another one that's here. That's 1, 2, or 3. And then this has to be 1 from 4, 5, or 6. Okay. So there's 2 from 4, 5, or 6 here. There's 1 from 4, 5, or 6 here. And there's 2 from 1, 2, or 3. There's 2 from 7, 8, and 9 here. Okay. This is at most 11, right? You can only have 4 and 7 here at most. And then it has to be 1, 2, 3, 1, 2, 3, 1, 2, 3. Or it'd be 1, 2, 1, 2, and that's 3, right? If that's the case, this can never be more than 8. Because 11, yeah. So this could potentially be 4, 7. It could be 5, 6 also. Though, actually, okay, hold up. These 2, that's actually one interesting thing. What is the most these 2 can be? Right? Because this is 23 at most. This is 20 at most. This is 17 at most. But it could be down to 15, right? If it's 15, this would be 15. What's the most this could be? So say you had 15 and this was 6. That cannot work. If this is 15 and this is 6, that would be 21. So this would be 21. This is at most 3. This would have to be 24, but that's not possible because 24 is 7 plus 8 plus 9, and that would kill, that square would not work. So this is at most 5. So it could be 1 through 4, but we don't know. So this is 1 through 4. This adds up to at least 15 and at most 17. So this is 15 to 17. This is 18 to 20. So again, 15 to 17, 18 to 20, 21 to 23. So this is also at, okay, so if this was 15, this would have to be, sorry, yeah, if this is 15 and this is 3, this would be 18. 18 would be 4, can be up to 5 away from 25. So this would be 1 and 4 at most. Okay. So this is at most 11. 9 could potentially be here. 8 could potentially be there. Uh, hmm, that's a question. That's a good question. What does this have to be? So this is at most 24, right? So if this is 24, say this was 24, this would have to be 3, right? If this is 24, right, because we know this is at least 18. So this is at least 18. So if this is 24, this would have to be um 3, right? So that's 27. Then you do 27 plus 18 adds up to 45. Oh, that's interesting. Again, so this is 18, 19, or 20. Can this ever be? I guess it could be 7. Yeah, that doesn't mean anything. So this is at least 18, but at most 20, right? Obviously, this could be 24, in which case it would be 7, 8, and 9. Oh, that's interesting. So if this is 7, 8, 9, this is 3, this is 1, 2. None of these can be 7, 8, or 9. So this becomes 1, 2. This would have to be 4, 5, 6. So this would be 3. This would be 1, 2. I mean, that seems to work. Okay. This is 7, 8, or 9. This is 7, 8, or 9. This could be less than 7, 8, or 9. Hmm, interesting. This is 2, this is 2, this is 2. So this is the same as this. This is 11 at most, but that doesn't limit anything. This could be 7, 8, and 9, so that does actually work. This is at most 7. So what is the least value this could be? Since that's at most 7, if this is, okay, actually, let's say this is 7. That's interesting. So if this is 7, this has to be 1, 2, 3, 4. So this is 17. So this cannot be 4 and 7. This is 17, which means this has to be 17, which means this has to be 1, 2. So this cannot be 1, 2. This is 3, 4. So this would have to be, oh, that doesn't work, does it? So this is 17, which makes this 17. So this totals 20, which makes this 20. This has to be 23, but the problem is that then this is 6, 8, 9. So this cannot be 8 or 9. So the 7 is right out. The 7 cannot be there. So this cannot be 7, which means this can't be 6. Can the 6 work, though? Maybe? Could be 1, 2, 3, 4, 6, which is 16. Hmm. This cannot. Oh, who's that? That's a hair. Sorry. This cannot be 7 either because of the same problem, right? If this is 7, that eliminates 7 from here, which means this cannot be 6, 8, 9, which would be 23. But then that means this is 22 at most, which means this is 19 at most, which means this is 16 at most. But 16 plus 3, or 16, but we already know this is 17 because has a 7. So this can never be 7. So we know 7, 8, and 9 are all here. I don't know what that really tells us. Actually, I do know what that tells us. This has to be 7 and 8? No, it doesn't. No, it doesn't. No, it doesn't. Never mind. That doesn't tell us anything there. We do know this has to be 7, 8, and 9 here. I'm just gonna, yeah, because we know we don't have a 7 here. 6 works okay. It's fine. Okay, so now this can only be 10 at most. So this cannot be 8. Oops. Right? Because this can't even be 5, 6 now. And it couldn't be 4, 7, or it can't be 4, 7 because there's no more 7. So this is 10 at most. So this is 10 at most. We don't know which though. Can this actually be 4? I don't think so, actually. Say this is 4, right? Yeah, say this was 4. None of these can be 4. So either this is 4 or it's 1. This is 1, 2, 3, 5, 6. If this is 1, 2, 3, 5, 6, this is set that equals 17. So this would be 17. So this is 17 plus 3. So this would have to be at least 20. And you have 24, which it can't be. And then 25, which it definitely can't be. So this cannot be 4. Can it be 3 is the question too, right? If this is 3, say this was 3, right? If this was 3, that means either this is 3. Okay, let's go the other route. So say this was 4, right? Then this would have to be either 4. This would have to either, right. So say this was 15 still. This would have to add 5 to it, right? So this would have to be 20 again. And then this would be 24 plus 1 is 5, 25. So that's not possible. So it cannot be 4. We know that for certain. It cannot be, this cannot be 4. Oops. This cannot be 4. Can it be 3 is the question. If this is 3, and say this was 15. So if you have 15 plus, or actually, if there's no 3 here, no, there has to be a 3 here. We know there has to be a 3 here. So say it's the minimum. So you have 1, 2, 3, 4, 5. So it's 15. This is 15 plus 1 plus 3. So this is 19 at least. This is 19 plus 3 is 22 plus 1 is 23. So this could be 6, 8, 9, and that actually is valid. So 3 does work there. Okay. So this is at least 15. This could be 30. If this is 15, right? Obviously this is 30 and this set is 30. This is at least 10. Hmm. Okay. Hmm. This does not limit things very much, I can see. Maybe the center box can limit things. Interesting. Okay, so this is at... we don't know what the minimum is. The maximum, so it could be 17 for these three. So this could be 16 maximum, which doesn't tell us much. But if it is 16, this is 7, 9. Hmm. Oh, this is at least 6. Right. This is at least 1 plus 2 plus 3. So this cannot be 1 here specifically. It could be 2, because this could be 2 and 4. Hmm. Say this is 2 and 4. This would have to be 1. Again, this would be 5. So this would have to be 15. So this would be this would be 15. This would be 20. And you have to have 1 and 2 and 1 and 2. So this would be 1, this would be 2. This would be 6, 8, 9. So that seems valid. Potentially. So for this, at least one of them has to be 1 or 2. Maybe both. It could be 1 and 2. That doesn't tell us very much. This is at most 16, but that doesn't limit very much. What's the minimum? 15. So the minimum would have to be 6. So it's 6 through 16 is these two digits. Still could be 6 because it would be 1, 2, 3. Right? And this would be 15. So you have 1, 2, 3. This would be 4. This would be 1. This would be 1, 2. This would have to be... So this would be 5. Which would mean that's 18. Yeah, that seems reasonable. So this would be 1, 2, 3, which works. One thing we know is this is at least 10. This is at least 10. Well, I mean, yeah, it's probably much more. This is at least 10. Hmm. This could actually be 7. This could be 17 even, though. Hmm. Hmm. Let's take a look at some other possibilities. Okay, so say this was 6, 8, 9, right? Say this was 6, 8, 9. This would have to be 7. So this has to be 1, 2, and 4. This cannot be 1, 2, or 4. This is 3, 5, 6, which doesn't work. So it cannot be 23. So this is at most 22. Same with 5, 8, 9. Interesting. So it cannot be 6, 8, 9. That doesn't work. It could be 4, 8, 9. because then that would be 7. This would be 1, 2, 4. So 21 does work. 23 does not. So 489 does work. 579 is also 21. Can it be 589? This would be 7. This would be 1, 2, 4. So it cannot be 589. Can it be 679? So 22 through 589 does not work. So we know it cannot be 23 then. So this could still be 1, 2, 3, 4, 6. Because this could be 16. 16 plus 3 is 19. 19 plus 3 is 22. So it could be that. So this could be forced to be 6 still. But let's calculate it out. 589 does not work, right? If this is 589, this still becomes 7, which means this is 1, 2, 4. And this would not be, so this would have to be 3, 5, and 6. But the problem is the 5 is already there. So it cannot be 589. And I think it can't, well, it might be 679. Okay, what about 679, which is the other possibility for 22? Right? This would be 16, because 679, which means this is 8. So this can no longer be 6. It's 1, 2, 5. So therefore, this is 6, and this is 6. So therefore, that doesn't work for 22 either. So we know then this is a guaranteed 21. So therefore, this has to be 1, 2, and 1, 2. This has to be a guaranteed 18. So this is 18, which means all of this is 18. So this has to be a guaranteed 1 and 2. This has to be a 3, 4, and 5. And this has to be, so this has to equal 30. So this has to be 15. So we know for certain this adds up to 15. Okay, this can't be 5. This adds up to 18, and this adds up to 21. So we've guaranteed that. Interesting. This has to be 1, 2, 6, 7, 8, 9. This is also 1, 2, 6, 7, 8, 9. This can't be 9, obviously. This can't be 9. This is at most 7. So this can't be 7 or 8. We don't know if it's 1 or 2. But, oh, interesting. So either this, so this is at most 7. Okay, well, geez. So this can't be 3. This could be 6 or it could be 7. So we know this has to have a 1 and a 2. This has to be 1 and 2. This is at least 13. So this has to be 4, 5, 6, 7, 8, 9. At least. This is 1 and 2. So this cannot be 1 and 2. Well, it can be 1 and 2 because of this anyways. But we know these 3 specific ones have to have 1 and 2. This is 4 or 5. It cannot be 3. If this, say, if this is either 1 and 2, in which case there can't be 1 or 2 anywhere here, or this is 6 and this has to be 1, and that's 2, 5, right? So either way, in this is either 1, 2, 1, 2. Okay, this can't be 1, 2. So this is 3, 4, 5, 6, 7, 8, 9. This could be 1. Or it could be 3, 4, 5, or 6. Yeah. So this is either, so 1 and 2 cannot be anywhere else in box 5. So this is 3, 4, 5, 6, 7, 8, 9. Okay, so this is 3, 4, 5, 6, 7, 8, 9. And this is also 3, 4, 5, 6, 7, 8, 9. Okay. So this cannot be... Okay, so we know this is 15. So if this was 6, if this was 9, this would have to be 6, which would mean this is 1, 2, 3, which is not possible. So this cannot be 9. It cannot be 8. If this is 8, this is 7, which means it's 1, 2, 4, which is also not possible. So this cannot be 8. This could be 7, in which case this is 8, and this could be 1, 3, 4, which is possible. So the 1 is either here, so where it's 1, 6, and that's 2, or this is a 1 or a 2. This could be 1, 2, 6, so it could be 1, 2... Can it be 3? It could be 3. 1, 2, 3, 4, 5, 6, 7, 8. We don't have a guarantee here. This cannot be a 4. If this is 4, 4 plus 1 is 5, which it can't be. 4 plus 2 is 6, which it can't be. And 4 plus 6 is 10, and everything else is higher. So this can never be a 4. Which means, one of these has to be 1, 2, or 3. Which means no, there is no other 1, 2, or 3 in this thing, in this space. So this is 4, 5, 6, 7, 8, 9. So we know the 4 is one of these 3. So this has to have one from 1, 2, or 3 at least. One and only one, I guess. Okay. That doesn't tell us very much, unfortunately. Still. So this is 15. This is 21. Okay, so we tried 4, 8, and 9, and that works. Because then this would be 7, this would be 1, 2, 4. This would be 3, 5, 6. Yeah, so that works. So 4, 8, 9 works. What are the other 21s? I think it has to be 5, 7, 9, and 6, 7, 8. So, what does that mean? Okay, let's go through again those scenarios then. So, say this was 4, 8, 9. Then we know this is 7. This becomes 1, 2, and 4. This is 3, 5, 6. This is 1 and 2. Right? Which means this would have to be 3. This would have to be 9. And this is 3, 6. Yeah, so that works. If this is 5, 7, 9, which is the second version of 21 you could have. 5, 7, 9, yeah. That's 12 plus 9 is 21. If this is 5, 7, 9, this has to be 8. The 5 cannot be here, so this has to be 1, 2, and 5. Which means this is still 1, 2. This is 3, 4, 6. Oh, interesting. And this is 1, 2, 1, 2. And this has to be 3, 6, and that's 9. If this is 6, 7, 8, this has to be 6 because the 6 can't be here. So this becomes 1, 2, 6, and that's 9. And again, this is 1, 2, 1, 2. This is 3, 4, 5 in this case. So this is 1, 2, 1, 2. There cannot be a 1, 2 here. This has to be 3 and 6 again. So this, and then we know for certain this is 1 and 2. So this can't be 1 or 2. So this is 1, 2, 1, 2. We know this is 6. This is 3. This is 9. So this is always the case. So this is 7, 8. This can't be 6. This can't be 6. None of these can be 6. This can't be 9. So 9 is one of these 4. So this is 3 and 6 no matter what. So this can't be 3. This can't be 6. 3 is one of these. This is 7, 8, or 9. This is 7, 8, or 9. This is 7 or 8. So this cannot be 7 or 8. So this is 1, 2, 3, 4, 5, 6, 9. So we know 1 and 2 are here. We know 1 and 2 are here. This could potentially be 2 and 5. Right? So we know this is 3, 6, 9. So 3 has to be here. Okay. So this is 3, and it could be with 4 or 5, or 4 and 5, or 4 and 6, or 5 and 6. Um, this again is 3, 4, 5, 6, 7, 8, 9. This can't be 7 or 8. This can't be 9. We know this is 18, right? So this is 21. This is 18, and this is 15. Okay. Hmm. Hmm. Interesting. Okay. Okay, I see one thing. So 1 and 2 cannot be here. So this is 3, 4, 5, 6, 7, 8, 9. Because this has to be at most 1 and 2. 1, 2, 4. So, and then 1, 2, 3 is the other one. Let's say this is not 1 or 2 either. If this is not 1 or 2, where can the 1 and 2 be in row 1? It has to be both be here. But this is then would have to be 3 plus 4, which is not possible. So this cannot, so this one we know for certain has to be a 1 or 2. Now, where can the 1 and 2 be in row 1 now? One of them has to be in 1 or 2. But we also know one of them in box 2 has to be in these two, one of these two pair to form a 3, 4, or 5. Therefore, this cannot be both 1 and 2, so it can't be 3. So this is 4, 5. This this has to be 3, which means we know this has to be 1, 2, and 4. So this has to be 7. So this can't be 4. This is 5 or 6. This has to be 5, and this is 2. This is 4. This is 1. This has to be 1, 3, because that's the only thing that adds. So this becomes 1. This is 2. This can't be 4. This can't be 4. This is 1, 3. So 1 and 3 cannot be here. This is 1, 2, 4, right? So this is 1, 2, 4. This can't be 5 anymore. This is 5 and 2 because it must add up to 7. This is 1 and 6 or 2 and 5. We don't know which. This is 1 and 3. The 2 has to be here. So this has to be 1. So this cannot be 1. This cannot be 4. So the 2 has to be somewhere here. The 1 has to be here. So this is 1. So this is 2. This is 1. This is 2. This is 5. So none of these can be 5. This can't be 5. This can't be to the 2, so this has to be the 2. So we have 1, 2, 3 here. So this can't be 3. This can't be 2. So all the 2s, we don't know where. This is 2. Okay, so this is 2. This is 4. This cannot be 7, 8, and 9. Well, okay, you couldn't be anyways. So this is, okay, so we know this is 21. So this is 18. Since this is 18 and this is 4, 18 plus 4 is 22. So this must add up to 23. Okay, so 3 can't be here anyways. This must add up to 23, right? Okay, so this can't be 1 or 2 either. This cannot be 1 and 2. But in this cannot be 1 or 2. Okay, so let's just do this. Okay, so 1, 2, 4, 5, 7, 8. So this can't be 1 or 2. This cannot be 1 and 2. So where in column 3 can the other 1, 2 be? It has to be here. So this is 1 or 2, and this has to be 1 or 2. So one of these is 1 or 2. This has to be 1 or 2. This has to be 1 or 2. right? So this is 4, 5, or 6 here. We know there's a 3 here. I guess it could be 1, 3, 4, 5. Yeah, that's possible. This is also 4, 5, 6, 7, 8, 9. I can't type, so that can't be 9. So we know 1 is somewhere here. We don't know which, though. 1 of 1 or 2 is here. We don't know which. It could be 1, 3, 4, 5, in which case this would be 3, 9, which is fine. This, okay, so one thing is, though, this has to have 1 from 1 or 2. So this is at most 2, 8, which is 10. So this cannot ever be 9. It cannot ever be 8. This could be 7, but this can't be 7. So this could be 10. It cannot be 3 and 4. Oh, it could be 3 and 4. Because it could be less. So 1 of 3 or 4 has to be here. We don't know which. This could be 3, which would make this 12. So this is possible. Wait, but this is 12 at most. So then this cannot be 9. So this can't be 9 and this can't be 9. Again, so this is 15, which forces that to be 15. This becomes 18. This 18 plus 4 is 22. 45 minus 22 is 23. So this 4 adds up to 23. So it could be 4, 8, 9, 5, 7, 9, or 6, 7, 8. So if it's 4, 8, 9, this could be 4 or 9. 4, 8, 9. It could be 5, 7, 9, in which case this is 5 or 9. But if it's 6, 7, 8, this one has to be 6. So this cannot be 6. This can't be 7 or 8. So 7 and 8 have to be here, right? So it could be 7, 8, and 6, 9. Or 6, 9, and 7, 8. Those both work. This is 3. Oh, wait, we know exactly how much this is, right? So this has to be 23. So, oh, we know exactly what this is then. Okay, right. So again, this was 15, which means these 3 are 15, which means these 5 are 18, which means this 3 are 18. So 18 plus 4 is 22. 45 minus 22 is 23. So these 4 add up to 23, but these 3 have to add up to 23 also. So we know then this, and the only way you can form a 23 from 3 distinct digits is 6, 8, 9. So there's no 3, 5, or 7. So this is 6, 8, 9. This cannot be 6, 8, or 9. So this can't be 6, 8, or 9. So this is a 5. So we know then this is 6, 9, and 7, 8, and 6, 7, and 7, 8. This can't be 7. So this cannot be 6 or 8 or 9. So this has to be 3, 5, 7. This can't be 7 then. So this has to be 6 and 9. So this has to be 7 and 8. This can't be 7 and 8. This is 6 and 9. This becomes 2, 4, and 8. So this is 3 and 5. 3, 5, or 7. So this could be 8. So, okay, this cannot be 5. This can't be 5. This can't be 5. There's no 3 here. So this has to be 3. Which means this can't be 3. 4, 6, or 9. So it could be 4 or 9. This would have to be 5, 7 if that's the case. Okay. So this is at most 12 still. So that still seems okay. Okay, this is combination of 4, 6, 7, 8, 9. Okay, right. So this cannot be 9 because this is at most 12. And we have 3 digits here. Cannot be 9. Whoops. This cannot be 9. This cannot be 8 because of the same problem, because this was at minimum 4 and 8. So this is at minimum 4 and 8. It could be 4, 7. So this could be 1, 4, 7, 4, 7. It cannot be 6, 7, though. So the 4 is always here. It could be 4, 6. Ah. So this has to be either 4, 7 or 4, 6, which means these two add up to 10. But this can either be only 8, 10, or 12. So with an additional 1 at least, this is at least 11. So this cannot be 8 or 10. So this has to be 12. So we know for certain this is 12, which means this is 12. So this is 3, 9, 4, 8. It cannot be 6 or 7. So this is 3 or 4 with 8 or 9. This is 3 or 4. Okay, first of all, this can't be 4, right? So this could be 3 or 4. It would have to be with 6 or 7. So it could be 3, 6, or 3, 7, or 4, 6, and that's it. So this cannot be 4 or 5. This has to be 1 or 2 with 7 or 8. So it could be 1, 8, 2, 7, or 2, 8. And therefore we have, this is 7, 8, this is 1 or 2, this is 1 or 2, 7, 8. So this cannot be 1, 2, or 7, 8. This can't be 1, 2, or 7, 8. So this is 4 or 5. And this is 4 or 5 specifically. This is 3 or 4. This cannot be 4, 8, 9 because we know this is 3 or 4. And if it's 4, if this is 4, 8, 9, that makes this 3 and nothing, which is not possible. So this cannot have a 4. So we know this is 7 with an 8 or a 9. So it's either 5, 7, 9 or 6, 7, 8. So this is 6 or 9, so this cannot be 6 or 9. This is 6 or 9, 6 or 9. This has to be 4, which means this is 3. So this is always 3, and it's with a 6 or a 7. We don't know which. So this is 4. This cannot have a 7. It has to be 5, 9, or 6, 8. This can't be 3, so this has to be 4, 8. So this cannot be 8. This has to be 5, 7, and 9. So this is 6. This is 8. This is 9. This has to be 6 and 8, so 8, 6. This is 7, so this has to be 2 and 8. So this is 1, which makes that 3, 1. This can't be 1. This can't be 6. This can't be 6. 2 is here, so this can't be 7. This can't be 2. So this is 1, 3. No 3, 4, 6, 7, 8. So this is 5, 9, so this can't be 9. This is 4, 8, so this becomes 1. It cannot be 2, so this has to be 4, 7. So this can't be 7, this can't be 7, this can't be 8, so this is 9. This is 6, 9, 6, 8, 7, 7, 3, 4, 8. This is 9. These are both 7 and 8. So this has to be 6 because this can no longer be 1, 2, 6. So it's 1, 2, 5 or 1, 2, 4. This is 4, 5. This has to be 5. This is 7. This can't be 5. This has to be 8. So we have 8. This is 1. We don't know what this is. This has to be 2. This is 8. So this cannot be 6, 7, 8. It cannot be 4, 8, 9. So this has to be 5, 7, 9. So this has to be 5, 7, 9, which forces this to be 8. And that has to be 2 and 5. This is 4. This is 7. This is 8. This is 7. This is 4. This is 5. This can't be 1. This is 4, 7. This becomes 3, 6. So this is 4. So this is 4, this becomes 8. This is 4, this is 2, this is 2, this is 4. This has to be 7, 4, 5, 7. This is 3. This can't be 3. The 1 has to be here. So this is 9, 5, 7. This has to be 3. This is 6, 3, 9, 5. This is 6. This is 9. And this is 6. And that's the solution. Wow. We are in darkness now. And that was that was pretty clever. I like that. Yeah, just finding out what sections had to equal what sections, and then what are the minimums for those. It's definitely pretty tough. So this was definitely a hard puzzle. And anyways, I hope you enjoyed the solve, and I'll see you next time on Frank Puzzles. Take care.